Everyone, welcome back. So we've got another truss. I'm going to use the method of joints to solve it. So I'm going to follow the same exact process like I always do. So first what we do, we turn this into a free body diagram. So I've got a pin support, so it means I got a force going up and a force going in the horizontal direction. I'm going to draw it to the right, even though I can see from this pretty clearly that it should be going to the left. Doing that because I want to use the same method every single time. Rolling support right here is going to be perpendicular to the ground, which is its horizontal, so force going up. Now I'm going to name those. So that'll be force C, this will be force A in the Y direction, this will be force A in the X direction. You can use horizontal and vertical if you want to. I honestly prefer X and Y just because that's what I use in all my other classes. Now which one am I going to solve for first? Well, I'm going to do some of the forces in the X direction because if you're looking at this, there's only two forces in the X direction and one of those is unknown. So it's pretty simple. So it'll be equal to 300. That'll be plus force AX. It's all equal to 0. And so when I solve, I get force AX is equal to negative 300. Wunderbar. Now, second step is I need to solve for either FC or FAY. So I'm going to do it like I normally do, and I'm going to take the moment around point A. And so let's figure out what direction everything's going to spin. So first off, okay, that's going clockwise, so that's going negative. Also clockwise, that's negative. That one's going counterclockwise, that's going to be positive. Do not worry about the direction that the forces are pointing or their direction their distance vector is pointing. Whatever it is, just look clockwise or counterclockwise. That's how you tell negative or positive when it comes to your sum of the moments equation. So that's going to be 300, and that's a horizontal force, times the distance, which is the height. And it didn't give me that, but I'll go ahead and tell you that sine of 30 degrees is equal to 1/2. So this would be 6. So that'll be 300 times 6. Then I have this vertical force times a horizontal distance. So both of those are negative. 600 times 12 plus 24 times FC. So with that, okay, I have, let's see, 1800 here, 7200 there. So that would mean that FC is equal to 9,000 divided by 24, which, let me pull my calculator. Be 375 pounds. Okay, so let's erase all these crazy arrows. I only do those just so you can see it a little bit easier when it comes to visualizing why I'm saying something's counterclockwise and clockwise. And it works really well. It works really well. Unless you purposely try to be weird, like where you do wrap it all the way around, it's not going to mess up. Okay. So with that in mind, let's put that 375 here. And now I have one more equation and I have one more force to solve for. So some of the forces in the y direction is going to equal to 600 down, so it's negative, plus 375 plus force AY. And I solve so that force AY equals 225 pounds. 225 pounds. Okay, so I have all my reaction forces now. And now I can use those to solve for the internal forces within these different members of the truss. Now, if you haven't done so already, go ahead and write down all these numbers because I'm about to erase this work over here. Now, this is a video. You have enough time. You can always rewind if you need to. Okay, erase it all. It's all gone. Deleted. Now, I have a lot to solve for here. I have 4 members. Last time I only had 3. And so, not quite sure where to start. Well, I'm going to do it exactly like I did last time. There's only 2 members here, which means there's only going to be 2 forces going away from it. So I'll start there. So first I'm going to redraw that. Okay. If I name everything, that's force CD. That's force BC. And then we have 375 going up. And there's a 30-degree angle. Now what you might be able to notice immediately is there's only one unknown that points in the vertical direction. So you only have two equations. One's sum of the forces in the y direction, which is vertical. So you might want to start with that one. So I'll go ahead and do that. Sum of forces in the y direction is equal to force BC. I only want the y component. So if I'm redrawing it a little bit, that's force BC. I want the vertical component. Well, that's going to be opposite over hypotenuse. Opposite over hypotenuse is equal to sine of 30, which I told you last time means it's one extra 1/2. That's 1/2. Plug it in your calculator. And that is going to be plus 375 pounds. Okay, that's all equal to 0. What this tells you right away is that we have made a mistake, that FBC is actually going to be pointing the opposite direction. We're okay with that. Let's leave it because that tells us it's in compression, and compression is negative. So that's in compression. Remember, you either keep a negative sign or you put C. Don't do both as it might get confusing. So I'm just going to circle this way now. And now I should be able to calculate what some FCD is. So some of the forces in the x direction, that will equal to negative FCD. Now here's where we got to be careful because the horizontal component, as we have drawn this, is pointing in the negative direction. That's as we have drawn it, okay? Remember that. So this is adjacent, so that would be minus FBC, and that's cosine of 30 degrees. Now remember that FBC is negative, so you would add in a negative number, and you would get, okay, so this is plus 750. Be very careful when you're writing out your equations that way. If you suddenly switch and you're just going to say that this is positive but in compression, you need to switch the direction of your arrow. You have to switch the direction of your arrow. Don't forget to do that. Now let me go ahead and plug this in my calculator. So 750 cosine of 30. Okay, so 750 times cosine, oh my, sorry, 30 cosine, then times 750. There we go. I accidentally multiplied it twice. 649.5. That seems reasonable. Since it's positive, that would be tension. Okay, so we have 649, and that's in tension. We have negative 750, so that's compression. I'll just get rid of the negative to make it a bit simpler on myself. As a note, this is technically a different member. Even though they're in one single line, there's a joint in between, which makes them two different members. We're going to see that that doesn't matter in this particular case. In some cases it will though, so don't just always assume that they're one member. Okay, so let's go ahead and erase everything. And keep on working our way through it. So what I'm going to do now is I'm going to pick point D and work there. So at point D, I have force AD going one direction. I have 649 going that way. I have 600 going down. And I have force BD going up. What's interesting is you might realize that there's only two forces in the horizontal and two forces in the vertical direction. And there's one unknown for each, which means you have no trig. All you have to do is say that force AD is equal to 649 pounds. And force BD is equal to 600 pounds. And you're done. I can write that out if you want to. It's just sum of the forces in the y is equal to force BD minus 600, which equals 0, and you just solve. So these are glorious. Whenever you find a place where there's this perfect cross, it is a beautiful point for you and it will make things a lot simpler. So I'm going to go ahead and type those in. So that's going to be 600. Both of them are in tension because they were positive when I was pointing away. Now let's go to this last point. Now you might be thinking to yourself, well, at this point it's obvious that one is going to be the same as the other one. It's going to be 750 because this one's 750 and this is a big, nice symmetric truss. If the forces and loads on it were symmetric, then yes, it would be. However, we have this 300 pounds, which is pushing to the right. It's not pushing straight down. So the loading on this truss is not symmetric. And so the loads inside of the truss will also not be symmetric. Some of them can be, not all. Okay, now let's go to that last point. So I'll draw a free body diagram for it. And I have 300 going this direction. I have 225 going up. I have some unknown one going up in this direction possibly. And so that would be force AB. And then I have 649 coming over here because this is in tension as well. I have a 30-degree angle. Okay, I only have one unknown. It's pointing in the X or Y direction. It really doesn't matter which one. And so, you know what? I'm going to just go ahead and solve for it. Now, there's various ways we could do this. So you can choose the way that you want. One thing to remember is that all these have to add to algebraically sum to 0. So all their components have to sum to 0. And so you can actually make a force triangle out of this. But I'm going to do it the way we've been doing it. So I'll just sum the forces, and I'll do it in the Y direction. So it's going to equal to 225 plus force AB. If I look at this little triangle, that's 30 degrees. The vertical side would be opposite over hypotenuse. So that would be sine of 30. We've already learned that that's 1/2. So force AB is equal to negative 450 pounds, which means that it's in compression. And so with that, we have solved. I have 600 here, 649, 649, 750, and 450. And these are two are in compression, everything else is in tension. And I'm done. So I hope this helps you. I hope it makes sense. And I'll see you all next time as we start solving some problems with the method of sections. So thanks for listening. See you soon. Bye-bye.